Hey folks, okay, well, let's get into some details on the project for the course. Now, there might still be some tweaking over the course of the term if we realize that there's inconsistencies in either the source language or the target language, but hopefully there will be no further major changes here. So, again, the idea for the project itself is you're developing a handcrafted compiler, if you like, to go through and take our same source language, our wonderful language, and translate it into our target language, which winds up being a subset of Bash. So this is supposed to go through, do the scanning and parsing and error checking on the source code program, and produce the translation into our target program. So same idea as with the labs, it's just you're writing your own hand C++ program to carry out this process for you. So let's see what we can do in terms of details here. Let's see, again, the language is the wonderful language that we outlined for the labs and that you're becoming fairly familiar with. Again, keep in mind that over the course of the 4 labs, the specs for the language get more refined. There are more features added to the language, and the one you're using for the project is the final version from Lab 4. So this incorporates all the changes that are listed at the bottom of the language page. So all of the different changes listed there apply for the project. All right, so do make sure you stay up to date with that. It's pretty much something you're going to be doing in the labs anyways. The project will be made available through a Git repository. Actually, it's available now. The repository is called Project, and of course it's under CSCI 485, so do your usual fork and clone to obtain that. When you first grab it, all it's going to have in it is one little file called Getting Started that is just a link back to the page for the project itself. So you're going to be creating pretty much everything for this one on your own. And I'll go into details on what I want from it in a few minutes. Again, this must be strictly individual work, so there's no teams here. It's just you, no collaboration. The implementation that you pick is completely up to you. If you want to sort of start from the kind of scanner and parser code that I used in the course examples, you're welcome to do that. Of course, that was written in C, and you're probably going to want to write much prettier code and make it maybe a little bit more just a little bit nicer code in general. But if you want to use that as a starting point or use some of the ideas, you're more than welcome to. If you find other code out there that you want to use as a starting point, that is acceptable as long as, again, this has got to be handcrafted. You're not using tools to generate the code for you. You have to make sure that you've actually got the rights to use whatever it is, and you've got to include something that shows me that you've got the rights to use that. It's got to compile cleanly on our systems as per the rules that we'll go into in a little bit, and that can't require either Merlin or our tech wizard or me to go through and add anything extra in terms of libraries or installs or whatever. It's got to work out of the box with what we've got on our systems now. And you have to make sure that you reference the source that you got the material from. So those are things to keep in mind. Other than that, it's pretty much up to you where you want to take this. The language that we're translating to is just a subset of Bash. So there's just a handful of Bash features that are available for you to use. So whatever code your compiler, your translator outputs has got to be based on just this subset of Bash features, nothing else. Again, if it turns out that I've missed something that we actually require, then we can go through and tweak this, but this is pretty much the list that's available to you. So it's a very small subset of Bash that you've got to target. In terms of the contents, what I want you to put together for the project, so this has all got to be in that Git repository, of course, when you submit it. There's got to be a makefile that does suitable compilations, so a separate compilation of all the individual files, making appropriate use of the error flags, things like warnings all and warnings error. It's got to compile cleanly when you run this. There should be things like a make clean, right? Just basic core principles to follow here. There's got to be a bin directory that contains any of the executables you create, a source directory for your your CPP files, a header directory for the header files, an object directory for the .o files. Right? So you've got to follow this kind of a structure. A test directory that's going to have all of the source code programs that you use to test your compiler against, with subdirectories in that, one for source code programs that are valid Wanderful programs, and another one for the cases that aren't, so that you can show me, yes, it compiles all the valid things correctly, and it catches all the errors in the invalid ones correctly. So you've got this division of test cases, a README file that kind of outlines how to use your tool, and outlines all of the issues, all of the known bugs, all of the weaknesses in your compiler. And again, the idea is, if you tell me that this part is broken, then you're not going to lose as many marks as if you don't tell me and I have to find it out on my own. So that's something to keep in mind. README detailing all of the issues with your compiler. What does it do? What doesn't it do? And then a test cases file that just runs through and gives me kind of a short description of all those test cases that you created. So just a short kind of what the file name is, where it is, short one-line description of each. And for the ones that your compiler doesn't handle correctly, so anything that your compiler doesn't work as expected for, include just a short note on what's going wrong there. Again, so that I've got some idea of which ones at least you think your code works on and which ones it doesn't. All right, again, in terms of the source code, in terms of your compiler code, it's got to be all C++, must compile cleanly. It's got to use the dash wall and dash where. It's got to be good quality code, right? This is going to be kind of nasty code to read at the best of times. So if you're using lousy layout or poor design or poor commenting, you are going to lose marks for it. Right? This is a fourth-year course. I'm expecting that you've got good design principles, good coding principles by now, and I'm going to expect that you know how to write that. So you know what's good style, what's poor style. I'm expecting you to go through and adhere to that. All right, again, your compiler is reading the source code from standard input. So, your compiler less than whatever the source code file is. It's sending the translated code, right? That translation to bash is going to standard output, and warnings and errors go to standard error. So, again, just an example of running it, for instance. Please make sure that you're following these specs as closely as possible. All right, in terms of the marking for this beast, there's a lot of work to do something like this in grand, glorious detail. And different people are probably going to go in different directions, right? Some people are going to put a lot of effort into the scanning and parsing and then maybe lose steam. Obviously this is a big project and you've got other deadlines, I'm sure. But so the idea is there are more than 100% worth of marks here. So if you focus on some areas and do really well in those and are a little weaker in some of the other areas, right, that's acceptable. It is possible for you to get whatever we've got here, 135% on this. So again, there's 30% available for the scanning, tokenizing, 30% for the parsing, 30% for the context-sensitive checking, type checking and that kind of thing, 30% for the generation of the bash output, and then 15% for all of the other bits and pieces that are included in the project requirements. So for those first three, the scanning, the parsing, and the checking, the idea is that for those, the marks are going to be based on how well you handle valid source code, right? How well you tokenize, parse, and check valid source code, and on how well you detect and produce warnings or error messages for invalid code. And again, if you go crazy on the error checking and get wonderful checking for the source code here, and the code generation is a little weaker, that's again a reasonable trade-off. Just keep in mind what sort of balance of marks you're going for here. Again, for the code generation, part of the idea is just simply that your code actually works, that your bash code does what your source code would have done. But the other half is to actually produce reasonably efficient target code as well. If it works, but it's horribly ugly and 10 times as long as it needs to be, that's not going to get as many marks as if it's somewhat more optimized. So there's this balance going on. That infrastructure is essentially for things like the makefile, the directory structure that I specified, those test cases, the documentation, right, all of the things that go along with this. So again, it's possible to get a 135% on the project. If you want to go crazy and you've got the time to do it, wonderful. But obviously I'm not requiring or expecting you to do that. So pick and choose where you want your efforts to go and where you think things make the most sense for you and what you find the most interesting about this. So those are the ideas. Again, this one is due, I believe, April 16th. Let me double check there. Where are we here? So in our requirements, projects due 5 p.m. Friday, April 16th. So anything up to then. Late penalties are as usual for the lab specs up here someplace. So late penalties are spelled out. If you've got questions, please get in touch. I will try and make announcements anytime there's a tweak to the project specs, but hopefully we won't have too many of those. All right, I will leave it there.